All right, greetings everyone. The purpose of this video is to go over some of the prereq skills you will need for section 3.2. And the first thing we're going to look at is what is called factoring. Okay, so notice I have a bunch of expressions here, algebraic expressions, and these can all be factored in some way, which means they're kind of broken down into different pieces. So, for example, in the first one, the x squared minus 3x minus 10, excuse me. So this is what is called a trinomial, and it's quadratic, because notice the highest power there is a 2. And this can be factored, so that it ends up being something that looks like this. Something in a set of parentheses times something else in a set of parentheses. And those things in parentheses there are called binomials. I actually know in this case that because there's no number in front of the x squared here, that each of these is going to start with just an x. Okay. And then the next thing is we have to figure out what goes in the other parts of the parentheses. So right here, right here. In each case, it's going to be a number. And we got to figure out what those numbers are. And here's how we do it. Is we're going to look at the number here by itself and also the coefficient of the x. And what we want are two numbers that are multiply to, sorry, that's not how you spell multiply. That will multiply to that last one. And then add to the middle one. So can we think of two numbers that will multiply to give us negative 10 and add to give us negative 3? Oh, right. So we do minus 5 here and a plus 2 here. Okay. So notice, if we stop to check our work here, right? Negative 5 times positive 2 is a negative 10. And negative 5 plus 2 is a negative 3. And so therefore we know that this first expression here, the x squared minus 3x minus 10, that can be factored to x minus 5 times x plus 2. Now you could check to make sure that's correct. How could you do that? Right, if you wanted to FOIL out these two sets of binomials here, you should find that you would get this to start, or you get back to what you started with, okay? But I'm not going to do that right now. All right, let's skip down to the third one then. So we have r squared minus r. And in this case, since there's only two terms, we aren't going to use that kind of unfoiling or opposite of foiling technique we used on the first one. For this one, since there's only two terms, what we're going to do is look at each of the terms, so the r squared and the minus r, and think about what they have in common. And it looks like they both contain an r, right? So what we can do then is factor out that r. So I'm going to put r and then an open parenthesis. And then inside the parenthesis, okay, the first thing that we'll have there is, well, we got to think about if we take an r out of this r squared, what are we left with? Well, r squared kind of means like r times r. So if we take an r away, we just have r. And then minus, and then we have to think about if we take the r out of the second term, okay, you may think there's nothing left, but we do have to have a placeholder in here, so we're going to put a minus 1. So r squared minus r factors to r times r minus 1. And just as before, we could check that this works, because if we distribute in the r here, we should get back to this thing we started with. In this case, that is the case. All right, let's look at the last one now. So we have 3xy minus 6y. So again, we'll look at what's common between the two of them. And I see that both terms here between this one and this one contain y. Then the first one has a 3 and the second one has a 6. So here when we're factoring, we think about what divides both 3 and 6. And the answer there is 3. So in this case, we can actually factor out a 3y. Okay, well, let's look at what happens when we do that. So in the first term here, if we take out the 3 and the y, notice the only thing left is x. For the minus 6y, Well, if we take away the y, that's gone. And then we have to think about, if we take out the 3 from the -6, what's going to be left? And whatever's left, when we put it here inside the parentheses, it has to be able to multiply by 3y to give us -6y. So in that case, we see that what should be in here is a -2, since 3y times -2 gives us gives us -6y. So that would be our answer then, 3y times x minus 2. Okay? All right. Let's talk next then about simplifying radical expressions, or square root expressions at the very least. So we have a bunch of square root expressions here, and I'm not going to have time to go through all of them. For the first one, though, notice it says square root of 4, and we know that that is 2, right? Because 2 times 2 gives us 4. So 4 is a perfect square, so the answer comes out nice there. With square root of 32, however, right, 32 is not a perfect square. It's not a number like 4, 9, 16, 25, 36, so on and so forth. So we can't just write the answer down for this one. And we don't want to write the decimal from the calculator. So what we can do instead is think about, what is the largest perfect square? And again, I'm going to write these off to the side. Those are numbers like 4, 9, 16, 25, 36, so on and so forth. So what is the largest of those types of numbers that go into 32? Well, the answer in this case would be 16, right? And we know that 16 times 2 gives us 32. So what we can do is, under the root there, rewrite 32 as 16 times 2, since 16 times 2 is 32. And then roots have this nice property that if you have the square root or any root of something times something, you can break that down to be the square root of 16, or sorry, the square root of the first thing times the square root of the second thing. So in this case, we'd get square root of 16 times square root of 2, which then square root of 16 is 4, and we'd have square root of 2. Okay? Now, let's look at another approach to this same one. So sometimes it's not obvious what the largest square root is that goes into a number. So you might just guess, and if you guess wrong, that doesn't mean you're going to get the answer wrong. It just means you have more work to do. So let me give you an example of that. So I know that 4 goes into 32, and that 4 times 8 is 32. So I'm going to rewrite square root of 32 as square root of 4 times 8. From there, I can then break that apart as square root of 4 times square root of 8. And then square root of 4 is 2, so I have 2 root 8. But as we just saw a second ago, we're not done, right? That's not the final answer. So how do we deal with that? Well, what we do now is look at what's left under the root and think, are there any perfect squares that go into that? Well, for 8, that can be written as 4 times 2, because 4 goes into 8. From there, we can again write this as 2 times the square root of 4 times the square root of 2, breaking up the roots, which once we do that, okay, this would become 2 times square root of 4 is 2 times root 2, and then 2 times 2 gives us 4 root 2, okay, which is the same answer we had before. So, as you can see, if you don't get directly to the answer, that's okay. You can still get there in other ways. All right, that's all for now. Thanks for watching.